Okay, so today we're going to talk about the business cycle model with flexible price and wages. Okay, so this is kind of the last chapter of this class. Here's a roadmap. So we're going to look at two models. One is the real business cycle model. The other is the Keynesian coordination failure model. Both models are just going to use to understand business cycle facts, like we discussed in chapter 3. Right, so there's fluctuation, and then this fluctuation presents some patterns, particularly their correlation with output. Okay, we are trying to use these two models to understand these facts, but certainly there's a reason why we look at these two different models. This model, as we are going to see throughout this chapter, they fit well with the data, but still they suffer some problems. And then we are going to discuss some criticisms for both models. We are going to close this chapter by looking at more recent recessions with 2008, 2009 financial crisis, and this to see what are the potential failures and what are the potential remedies to these two important models. The key question we are going to ask, or we are going to address in this chapter, are the following. Number one, how does each model feed the data? Because we are trying to understand or trying to explain the data. Number two, what is the role for government policy in each model? Right, so we have a model to understand the behavior of the macroeconomy, but at the end, our goal is to see what we can learn from this model, what we can offer in terms of government policy, so that mitigate the fluctuation. Right, so those are the key questions we are going to try and answer in this chapter. So let's start with real business cycle model. Right, so here is overview of this model. Number one, so this model, based on this model, business cycles are caused by fluctuation in total factor productivity. What is total factor productivity? So in earlier, we talked about solo growth model, essentially. So this is solo residual, right? So what is solo residual? If you have a production function y equal to z times k, we have alpha and 1 minus alpha, right? So alpha is a capital share, 1 minus alpha is a labor share, z is a TFP. Okay, and then so the TFP, so we can back out TFP equal to y, which is the GDP divided by k alpha and 1 minus alpha. So in some sense, TFP is going to capture anything that's matter to the output, but it's different from factor input. Right? So input includes capital and labor, and hence, so TFP can interpret it with, say, for example, weather, so technology, regulation, institutions, right? So this is TFP. And this business cycle model, as I'm going to show you in the next slide, okay? So basically, they believe this TFP is the driving force for the fluctuation, okay? But for good reasons. Secondly, based on this model, there's no role for government to smooth business cycle. Why? Because cycles are just optimal response from the private sector to technology shock. Or in other words, so based on this model, our economy is on the efficiency front. There's nothing you can improve. Overall, this model fits the data well. So in terms of match with the fluctuation, in terms of match with the variability or the standard deviation, right? So now let's see, so why, so we believe the TFP is a leading explanation, a leading factor that causes fluctuation, or why this real business cycle model relies on TFP. So here we have two time series. So this Blue line is GDP. The red line is solar residual. Again, so how we calculate solar residual? Z equal to Y divided by K alpha and 1 minus alpha. Okay, so this Z is calculated by this formula. And the Y actually is referred to GDP. What we notice, there are two things. Number one, these two are track with each other. So whenever GDP falls, TFP falls. Whenever it rises, it rises. Right, almost simultaneously. This is number one. And then number two, so these things, I mean, so TFP is kind of persistent. When they fall, they're going to keep falling for a while. When it rises, it's going to rise for a while. Okay, so these actually, they just inspired economists. They use the TFP as a driving force to business cycle. But certainly, so the way we do is going to show up in the next slide. So we are going to introduce Z, I mean, the fluctuation Z in the intertemporal model we have discussed in previous chapter. And to see, so if Z change, so if Z increase, how would that cause Y change, N change, R change, W change, so on and so forth, and probably C, I, right? So how these things change. And then finally, so based on this change, we're going to see whether their patterns match with the facts, right? So this is how we do the modeling. So now this slides is going to summarize the real business cycle model, what this in a graphical way, right? All the things we are familiar with and or we have discussed. This is like intertemporal labor supply and intertemporal consumption saving decision model we have discussed before, right? And we even include this panel C that is from chapter 12. We talk about price and the money supply, right? So essentially, so A, so you have labor market clearing. That's going to give you labor supply and a real wage in equilibrium. B is going to goods market clearing, give you the real output and real interest rate. And the C, so just take the R and the Y, and then so we are going to see, so the money demand and the money supply, that's going to determine the price level. All right? Now let's see what happens when there's a TFP shock. So here we consider a positive TFP shock. So we got Z increase. First of all, if Z increase, that's going to lead to the marginal productivity of labor is going to increase. That immediately cause the labor demand to increase, right? Because the firm is going to make more profit. Labor demand increase immediately is going to lead to the aggregate supply is going to increase, right? So this is number one. Now, let's see how this is going to affect demand. So Z increase, as I explained in the previous slides, usually this implies Z prime is going to increase because the Z is persistent, meaning so when you rise, you're not going to immediately fall. With very high chance, you're going to stay high for the next period. If Z prime increase, and then so the households is going to increase C because their wealth is going to increase. They're going to increase I because they knew, so next period, so the productivity is going to high. Hence, this is going to lead to the demand increase. Now, in terms of real interest rate, what would happen? In one hand, if the aggregate supply increase, the interest rate is going to fall. On the other hand, if the demand, yeah, okay, so if you move from here to here, yeah, so interest rate is going to fall. But then so if the demand increase, right? So if the demand increase to here, and then you're going to see the interest rate rise, right? But in this diagram, we draw the case, a more reasonable case, which is the interest rate is going to fall. Okay? Why interest rates are going to fall? So largely it's because the consumer yes, they are going to increase consumption, right? But they understand this TFP increase is not going to stay forever. Yes, it's going to persist, but it's not going to stay forever. Hence, they are going to save a little bit, right? So that's going to drive down the interest rate because there's so much saving, right? So they're going to drive down the interest rate. So hence, so overall impact on the interest rate is going to fall. But now the lower interest rate, so essentially it's going to make the future leisure cheaper, right? Hence the current leisure is going to, so the lower interest rate is going to make, so the relative price of the leisure is W, I mean, future price of leisure is W divided by 1 plus R, right? So if lower interest rate, that means the future leisure becomes more expensive. And then the currently they are going to reduce their labor supply. Why? Because they are going to consume, they are going to enjoy more leisure because future leisure is more expensive. They are going to enjoy more leisure. Why? Because interest rate is going to fall. Why interest rate fall? As I just explained, right? Okay, so if households choose more leisure today and the labor supply is going to fall, that goes to this direction, right? But overall, so you can see the wage is going to rise. Okay. So to summarize, on the left side of this graph, so if Z increase, that's going to lead to Y increase, right? C increase, I increase, wage is going to increase, interest rate is going to fall. So that's what we have. That's what we have discussed based on the real side of the economy. Now, if we look at the price level, so Y increase, R decrease, based on the model we have discussed in previous chapter, that implies the money demand is going to increase. Money demand increase, that leads to the price level to fall, right? Or right here, price level is going to fall. So that's the real business cycle model, right? An important business cycle model fact is that the labor productivity, total factor productivity, so we call it labor productivity, right? So essentially, this is how much each worker is going to produce. This is going to rise, right? So look at it here. So when we have Z1, okay, and then so this is labor supply in equilibrium. So the slope, I mean, this is essentially this per worker, right? So just divided by L, divided by N, right? So essentially the slope of A and B equal to Y1 divided by N1. So that is per worker term, how much they can produce. This is labor, this is total factor productivity. Right. So now if you have higher Z, and then this entire thing goes up, and you can see, so AD versus AB, the slope increase. The slope increase actually just reflects the fact. So when average, sorry, I misspoke. When TFP increase, when Z increase, the average labor productivity is going to increase. So the average labor productivity, let's call it ALP, okay, average labor productivity. So this is defined as how much each worker can produce. So this is going to increase. That's a very key, important fact regarding to business cycle. And clearly this is consistent with what we observe in the data. Now, this table is going to summarize the key facts, right? So here we have variables. This is including consumption, say investment, employment, real wage, average labor productivity, right? In the data, these are all pro-cyclical, meaning, so when Y output increase or GDP increase, so each of those variable, if the pro-cyclical, meaning let's call X, okay, so like variable. If the pro-cyclical, it's increase. If it is counter-cyclical, it's going to decrease. Okay, from the data, that's what we discussed in chapter 3. So in the chapter 3, we have examined the business cycle facts. Okay. We have discovered those variables are pro-cyclical. Now our model generates exactly the same movement, pro-cyclical. I want to highlight a few things. So here we just talk about pro-cyclical, but we also look at variability or the magnitude of the fluctuation. See, when we look at business cycle facts in chapter 3, we knew that investment is very volatile. Its standard deviation is much higher compared to GP. It's like 3 times. And the consumption is less than 1. And the employment, all those things are less than 1. Right? And so in the quantitative version of the real business cycle model, as you're going to study in more advanced class, you will notice, so this real business cycle model also match in that direction, meaning not only qualitatively, this is qualitative, like in the direction, also they quantitatively, they fit the data well. Not perfect, but in that direction, right? So this just summarize the real business cycle model is a good model to understand the business cycle fluctuation. Right. Now here, I want to bring your attention regarding to the money supply. Right. So in the previous chapter, yes, we say so the co-movement of money supply with real economic activity is irregular, or you don't see much clear relationship between money supply, which is here, and the real economy, which is like Y, as we discussed in previous slides, right? And in particular, this is true since 1980. However, in the past, say for example, 60 and 70, or even earlier, money and output correlation has been important. Not only the important, it has been used as a policy guidance, like in 70, 80. So the central bank actually used money supply as their main policy tools to regulate or to mitigate fluctuation in the economy. So if we want to explain why money and output correlation may or may not rise in the data, and say something about cyclical property of price level, and then so we can use this model, or in other words, this model can still say something about the cyclical property of price level. Just imagine this model. If the central bank is trying to target the price level, now when Z increase, as we discussed previous slides, so Y is going to increase, R is going to fall, meaning the money demand is going to increase. So that just means we are going to move from P1 to P2, right? So Z increase, and then the price is going to fall from P1 to P2. So when I say the central bank want to target the price level, meaning they want to maintain the price stability, what they can do, so they can increase the money supply. So to maintain the price level, right? So in that sense, this is one of the implications of this real business cycle model regarding to price level. Okay. So now we are going to move to a slightly different model. Okay, so the goal is also to understand the fluctuation, right? So this is called Keynesian coordination failure model, right? So they just basically, they have like different view regarding to what causes fluctuation. Here is a summary of this Keynesian coordination failure model, right? So before I show you some details, the key things I want to highlight, the difference between this model and then the real business cycle model is that there's a room for government intervention in Keynesian coordination failure model. Or in other words, market may not be efficient. Market may fail. Okay, and then so that's going to give some room for the government to intervene to improve the allocation of improved welfare of our economy. So that's the key difference. Now let me just lay out the the key results of this model, right, or summarize. Number one, this model relies on strategic complementarity. First, this strategic complementarity implies aggregate productive function has increased in return to scale. And furthermore, labor demand is going to be upward slope, as I'm going to show you in the following slides. But let me explain to you what does strategic complementarity means. The good example is just think about if you want to go to a party in the weekend. So for example, you have a friend, so he's organizing a party. And clearly the more people go, and the more fun, and you're more willing to go. But without good coordination, you may not know who is going to go, who is going to stay at home, right? And then so you're gonna have a guess or verify. If you feel this is not a good party, nobody's want to go. And because it's boring, no one wants to go. And then you choose not to go, right? And then in reality, if everyone just do the same guess as you did, right? And then, so that just means, okay, most people not show up, it becomes a boring party. And you feel, okay, I was right. So I did not go. But on the other hand, so there's a good card. The other hand is you were very optimistic. You're very enthusiastic about this party. You feel, well, this is going to be a good party because now as we are approaching the end of the semester, everyone want to enjoy a little bit, want to celebrate a little bit. We should go. This is going to be a good party, right? And then turns out everyone has the same feeling. Everyone goes, and then this is just verified, right? This because it turns out it's a good party. It's a lot of fun, right? So here, so this strategic complementarity is show up as, so the more people go, and then the more fun the party becomes, and then so you are more likely to go, right? So this just complement with each other. So if whether I want to go or not, depending on whether other people go to join or not, right? But so where the increase in return comes in the example of this party, essentially, the more people go, there are more fun from the party, right? But what is constant return to scale, as we discussed in previous chapter? So essentially, so the marginal fun you're going to, or the overall fun you're going to get from this party is independent of the number of people show up. But in this case, as I just show you, indeed, so there's a increase in return to scale. But this not only happens to the party as I just discussed, it also can happen in our aggregate macroeconomy, right? Just imagine if each of the business invest and have innovation, and then collectively, so this innovation, this investment is going to benefit from each other or benefit the aggregate productivity. Hence, you're going to have increase in return to scale. So that's the starting point of this Keynesian coordination failure model. But that's not the end story. So with this strategic complementarity, first you're going to see increase in return to scale. So that's going to change labor demand curve. Instead of downward, why labor demand curve downward in the previous model? Let's go back a little bit. Okay. So look at here, labor demand is downward slope. Why? It's because the marginal productivity of labor is declined, right? But now, so here we have increase in scale, increase in returns to scale at aggregate level. Hence, if you look at individual marginal productivity of labor may increase. So that's going to lead to the labor demand. Labor demand is going to increase. And then, so this is going to lead to a potential multiple equilibrium. Then the problem is which equilibrium we are going to end up with. That's kind of uncertain, right? And then, so it could be the case we are going to bumping around between two equilibrium. Usually it's like good and a bad equilibrium. This bouncing around between equilibrium, so that's going to lead to the business cycle. Right, to summarize, so the GDP fluctuation in this model largely due to self-fulfilling waves of optimism and pessimism. Meaning sometimes you are very optimistic and then so you invest, you demand a lot of labor, right? And because you believe the marginal productivity of labor is going to be high, the economy is doing well. And then so you do that things, and then so you kind of you just make this belief becomes reality. On the other hand, if you're pessimistic, because you believe so the labor productivity is going to low, no one's going to invest, no one's going to demand labor as you did, and then you reduce your labor demand, reduce your investment, right? And then so it turns out that once you decide to do that, and then the economy indeed is in a bad equilibrium, in a low productivity, low output, and a low labor productivity, right? So this kind of justify your original pessimism, right? So then so you can see the economy is going to bounce around between this optimism and pessimism, right? And that's going to generate B cycle. So that's the key idea of this Keynesian coordination failure model. Now let's look at some graphs to have a better understanding of what I just summarized. Okay, our starting point is this production function. So instead of constant return to scale at the aggregate level, now we have increase in return to scale, right? So this is due to the strategic complementarity. So in the traditional model, or in the model we discussed previously, so usually the output functions look like this. Now you can see, so you can convex. Convex means in the margin productivity of labor is increased. Concave, as we discussed before, says marginal productivity of labor is decreased as you demand more labor, right? So this is a starting point, is the first difference. But this immediately implies the labor demand is going to increase. Why increase? Because more you demand, and then so you have an increase in return to scale in the aggregate level. The productivity is going to increase. That leads to in the individual level, your marginal productivity of labor is going to increase as well. Hence, you want to demand more labor. Remember in the previous model, so the labor demand is decreasing. It's decreasing with wage, right? Okay, so when wage rise, and then the labor demand is going to decrease. When wage falls, labor demand is going to increase. Now here is difference, completely different, right? So furthermore, so this is how the market is look like. Okay, so this is labor demand and labor supply, right? With a given interest rate. Now, in the next slide, I'm going to show you, or we are going to derive the output supply, or YS, output supply. On the very top, that is the supply curve. Okay, remember in the previous model, the supply curve is increased with interest rate, right? Why? Because interest rate rise, okay, and then so remember, so the 1 over R, so whatever is it, right? This is the cause of future leisure, right? So the W divided by 1 plus R increase, this is gonna fall, right? And then leisure in the future, leisure becomes cheaper, right? And then so you don't want to take much leisure today. Leisure is going to decrease today because future leisure becomes cheaper, and labor supply is going to increase. So that's in the previous model, in the real cycle model. Now in this model, what would happen? So if interest rate increase, right? So from R1 to R2, so the labor supply is going to fall. Okay, so why the labor supply is fall? Okay, so this is largely because of the, this is largely because of this is because of here, right? It's because of the strategic complementarity, right? As we just discussed in previous slides, right? Okay, so now if labor supply falls, and then output is going to fall, right? Hence, you can see, so this is a downward slope of output supply. Okay. All right. So now we can bring everything together as we did for real business cycle model. Okay, panel A, you have labor market. Panel B, you have goods market. And panel C, so that's the price or the money market. That's less important. Let's focus on here. Right? Labor, so the key difference from compared with real business cycle model is that now you can potentially have two equilibrium. This is aggregate supply. This is aggregate demand. What we had before, we have demand and supply. One's increase, one's decrease. Usually have one equilibrium. Now you have this strategic complementarity. So you have the demand is given, you have supply, but supply is decreased, right? And then it's possible you have two equilibrium. It could be the case you have one equilibrium, like you just cross with here, right? And maybe you have like a more equilibrium, like this, sorry. And you can have even more equilibrium. Let's say, for example, so this is demand, this supply, right? So those are also possible. But for now, let's just focus on the case with two equilibrium. That's enough for now, okay? So you have equilibrium here, you have equilibrium here. But these two equilibrium has different implications in one equilibrium. So Y is high and R is low. That refers to this one too. In other equilibrium, Y is low and R is high. But these two equilibrium is going to imply different price level. So this one implies MD is high and price level is low. And this one implies MD is low, price is high. Okay. So finally, so this model also has implications, but the same implications regarding to average labor productivity. Okay. So if you're in a high output equilibrium, and then your average labor productivity is high. If you're in a low level, and then your average labor productivity is low. Right? So to finish this model, right? Remember you have two equilibrium. And then, so depending on where you are, right, and what costs you. So let's say, for example, if you are in a high level, right? If you're in high, and R is going to low, right? But then, so immediately this is going to lead to C is high, right? Remember, so just you have a high demand. Investment is going to high, and also the labor supply is going to high. Or in other words, so this model is going to generate similar patterns as we have discussed in the repeat cycle model, right? All those things, all those variables, they are pro-cyclical, as we discussed, as we have found in the data, right? So this model, this data. So in the sense, this model just match all the business cycle facts the same way as our real business cycle fact. All right. However, so the main difference is that, so in this model, in this coordination failure model, there's room for government intervention, or there's a role for government to mitigate the economy. Right? Okay, so let's see, so how this government, how the government can help, right? So let's go to these slides. Let's just start with, let me see, start with this demand, okay? And we have originally we have this supply, this is the original equilibrium, right? So and then you have two equilibrium, one here and one here. Where we end up with is kind of depending on what you believe. And sometimes economists call this like a sunspot. Sunspot essentially is what happens in the sun, right? So, but this has nothing to do with our real economy, but this is like a signal. It's a signal to you. So should I be optimistic to our regarding our economy, or should I stay pessimistic? If I feel, oh, this the show of the sunspot is indicating I'm going to be pessimistic, and then we'll end up with equilibrium here. On the other hand, so we are going to end up with equilibrium here. And then so basically, the way we behave is essentially just follow the observation of the sunspot. And then why we need to follow this? Because there are two equilibrium. We don't know which one should I believe, which one should I follow, right? So that's kind of how this model works. Okay. Now, in this original model, you have two equilibrium. What the government can do? So if the government can increase, the aggregate demand or decrease the aggregate demand, actually in this case, if the government change the aggregate demand, so that aggregate demand goes to this line, okay, and then what happened? And then so there's going to be only one equilibrium, so because the aggregate demand is going to cross the aggregate supply curve at this point only. Now you can see, so the government intervention by changing government spending, by the way, is how they can just shift the aggregate demand, so they can just change their spending, right? So the demand for goods and service. And then so they are eliminate two equilibrium, one of the two equilibrium, or they end up with one equilibrium. So that's going to stabilize the economy, right? So that's, you can see, so the government can play some role in this model, right? But now, what is the problem with this model? Okay, so this coordination failure model, what is the main problem? So the main issue with this coordination failure model is that this model, as I explained at the very beginning, this model relies on increasing return to scale at the aggregate level. But however, if we look at the data, or economists have looked at the data, they didn't find enough evidence to support this increase in return at the aggregate level. So that's a potential problem with this coordination failure model. All right, so now let's go to the last part. Let's just bring this real business cycle model to reality, and both the real business cycle model and the coordination failure model. Overall, this model fits very well for the average business cycle, but they didn't do well if we just look at 2008, 2009 financial crisis. This recession is a little bit different. Okay, so their difference, or the key challenge that imposed to these two models are the following. Number one, there was a small drop in solo residual, or in other words, you really cannot rely on the real business cycle model to explain the huge drop in labor supply and output, because so the solo residual, or the TFP, dropped by very little, but the output dropped by a lot and labor supply dropped by a lot. Number two, price level is procyclical, meaning the price level falls instead of rise in the model. Okay. So what are the potential remedy, or what's missing from this model? Okay. Obviously, financial factors play an important role in this recession, right? However, the financial factor play no role in either this model. But by the way, what are the financial factors? This is what we discussed in chapter 10, I believe. So we talk about the collateral. We talk about the limited commitment. Right? So those things can have important impact on real economy. Because just say, for example, if you remember, so what is collateral, right? So collateral says, so your saving must less than the value of your collateral, your house, right? Or sorry, you're borrowing, whatever, okay? So now if the housing price collapse, and then so you can borrow less. If you can borrow less, even though you want to invest, or if you want to consume, you can, right? So that's what we discussed in that chapter. Now, if we add this financial factor in real business cycle model or coordination failure model, we may potentially explain those two discrepancy between these two models we discussed and what happens in reality. To finish part, let me show you a few slides regarding the data to kind of convince you what was the potential problem, what was the potential future avenue we can explore as economic research. So this one just show you GDP and versus solar residual. Look at this time period. GDP falls by a lot, particularly compared with solar residual, right? But this just says so that quantitatively, the real business cycle model is not able to explain the big drop in GDP because the solar residual drop very little. How can you generate a deep drop in GDP? This is number one. Number two, look at the investment. So the investment dropped by a huge amount, particularly compared to GDP. But this is not only quantitatively, this is not feasible to explain by either the real business cycle model or the coordination failure model. And finally, let's look at the price level. So when GDP falls, the price level also falls, right? But this is opposite to both real business cycle model and the coordination failure model, because in those models, so what we discuss is it's opposite, right? So when Z increase, Y increase, R increase, this implies the money demand is going to increase, implies the price is going to fall. Meaning, so if Z falls, P is going to increase. But now what happened here? So when Z falls, GDP falls, but the price level is also falls, right? And also, if we look at average labor productivity, okay, when GDP falls, it did not fall as those model predicts. As a matter of fact, it picked up quickly and even higher than compared with the pre-recession period. Okay, so those are the potential problems we face with this existing model. But as I just mentioned in the previous slide, so the financial factor can play an important role to explain those phenomena that this existing model cannot explain. Right? To summarize, what do we have learned in this chapter? In this chapter, we studied the business cycle model. We studied the business cycle. We proposed two theories that explain the fluctuation in real economy and in price level, right? Overall, these two models did a fairly good job to explain this fluctuation, right? But certainly it faced some challenge but in terms of the future direction of macroeconomics, and potentially we should include those financial factors or other factors that were missing in this model. And finally, I want to emphasize the key difference between real business cycle model and the coordination failure model. In the real business cycle model, all the fluctuation comes from the optimal response to change in TFP. But in coordination failure model, so the fluctuation coming from the household sentiment, or we call animal spirits, right? Sometimes you optimistic, sometimes you become pessimistic. And then, so that leads to economists bouncing around between two different equilibrium, up and down. Hence, in this coordination failure model, actually, it leaves some room for government intervention because government can potentially eliminate one of the equilibrium so that we can stabilize our economy.